I'll make that pretty much time, right? Shall we get started? And then lunch is just around the corner, so I'm going to try and make this entertaining as well, because like many of you, I'm sure I'm kind of hungry too as well. So we're going to look at debugging Java microservices remotely in Kubernetes with Telepresence. Now, oh, hands up, I've stolen this term remotely from the Influx folks. I saw them demoing some of like the technology I'm going to demo, Telepresence, at a conference, and I was like, remote, local, remotely? These folks are amazing marketers, right? So I'm going to steal that term. It'll all become clear what that means in just a moment, hopefully. I always like to start my talks with a TLDR. And if you're hungry, you can leave early with these key takeaways, right? The inner dev loop can be painful with microservices and Kubernetes. Now, there's just more things with microservices. Back in the day when I was doing Java monolith works, one thing that went wrong, one thing to work on, one thing to deploy. Lots more things with microservices. Kubernetes adds a lot more layers in the stack, right? VMs, containers, Kubernetes, all these kind of things. It's just quite hard to get that fast feedback sometimes. Telepresence, open source CNCF tool, Cloud Native Computing Foundation tool, proxies your local machine into the cluster. It's like my laptop is in the network of the cluster. I'll show you what that means with some demos as well. You get that fast Remocally dev loop, which means I can code some stuff locally while interacting with my remote services. So I can have this massive kind of dev environment online and have all my local tools and a few services I'm running on here playing around with and connect them like together, connect my local dev machine with the remote Kubernetes cluster. And it's all about making folks more productive, right? The company I work for, Ambassador Labs, we chat to a lot of folks who are just slowed down. After the initial excitement of microservices, the initial excitement of Kubernetes, they get a bit slowed down when things get going, right? So trying to get that productivity, the key thing here is about making us as developers more productive, sorry. And it is a CNCF project, open source. If folks haven't bumped into the Cloud Native Computing Foundation, they're amazing folks. Open source governance, like Telepresence is sort of the IP is owned by the CNCF, so you can contribute knowing that it's not one vendor looking after it, and you've also got some longevity in there. CNCF projects, they're neutral IP, so if a company goes bust or something, no biggie, that project remains within the CNCF. So if you haven't bumped into the CNCF, check them out. You may have heard of KubeCon. I'm actually going to do a shameless plug for my KubeCon talk, which is in Valencia next week at the end. But it's a CNCF project, and like all open source projects, Telepresence relies on you getting involved to make it successful, right? So this is me at Daniel Bryant UK on the interwebs. I work at Ambassador Labs, Kubernetes, fast dev loops, that's our thing. I've written a couple of books over the years. I see Jim at the back as though we're writing a new book, Mastering API Architecture, available on early release. Help put our kids through college, right? Go and read it. And I've also with Abraham and Perez, we did continuous delivery in Java a while back. I also write for InfoQ. Love getting involved on Twitters, LinkedIn, GitHub. Hit me up where you're at and love to chat. So let's set the scene, right? And it's a fantastic blog post by Mitch Denny. Unfortunately, it's 404 now. I'm not sure what happened there. But he talked a lot about inner and outer dev loops. And someone luckily has reposted it. So there's a different link you can find to there. But I think we all get this, right? Even if you don't practice test-driven development, there is this notion of that inner dev loop. You're just trying to get the problem done, right? You're maybe not relying too much on dependencies, or maybe you weren't back in the monolithic days, but maybe in the microservice world, your inner dev loop also requires you to interact with additional services, maybe to understand what does this service give me back when I call the API, this microservice, right? How does the way I'm calling this affect the response coming back? So you typically move from inner dev loop, coding, TDD, back in the day, lots of mocks, service virtualization, all that good stuff, right? And then once you're happy, you would then push it to this outer loop. Love me some Jenkins in this space, right? Grew up on Jenkins and Hudson and so forth. Many of the products out there now, but this is when you're often doing the bigger outer test loop. You're running a deeper kind of set of tests. You're getting a lot more deeper feedback. But obviously the outer dev loop is much more expensive. You've got to typically push code, get the feedback. There's a context switch there, right? Inner dev loop is where you want to spend most of your day as a developer. I think we can all agree. I hinted already, right, that inner and outer dev loop with Kubernetes, microservices, all these good things can be quite similar. Particularly if you want to figure out what's going on in the cluster and sort of do that system.out.print line, get that fast feedback. You often have to write some code, build a container, push it to a remote registry, deploy the thing to a cluster. Kubernetes, got to have some YAML in the mix, right? Then you do your test, then you verify. And this can be super slow, right? We'll come on to the kind of local dev setup in a minute, but I've definitely walked into companies where they've been going for quite some time, and this is they're in a dev loop now. They're trying to test something out. They literally do these steps, and the developers are just like, kind of, what's going on? Like just twiddling hands, reading Slack, reading Reddit, going on Hacker News, right? As soon as we get that context switch, it's really costly for us to get back into the zone of that inner dev loop, that fast feedback. A whole bunch of tools out there can help, right? I'll walk through some of these and happy to chat to folks afterwards. Like, I don't work for any of these companies. Like, I work for Ambassador Labs, who created Telepresence, but these are amazing tools that help automate the sort of the manual Docker build, Docker push, all that kind of good stuff, right? And over the last few years I've been doing this presentation, a lot of these tools have evolved really nicely. Skaffold, for example, doesn't just sync local file system to remote file system anymore. It can do some really nice tricks with just syncing class files in the Java world, for example. Draft, I think, has actually disappeared now. So last time I looked, don't worry about draft too much, but there's a big focus on automating the container build and container push commands, for example, and have it going hot reload in the background. Skaffold I like Skaffold a lot. I use Skaffold with Telepresence quite a bit for that reason. But sometimes you want that really fast inner dev loop. You don't want to do the Docker build, Docker push. Even if it is really automated for you, you don't want that. And you also want to use your own tools. You want to get local, right? You want to not be doing remote debugging. You want to be actually like in your IDE. Big fan of IntelliJ myself. Like to be in IntelliJ rather than, and local debugging rather than messing around with remote debugging. So people often kind of flip back, or they start in this place. They run everything locally or something locally. Now, if you're running everything locally and you're quite like a small company, product market fit, you can probably run everything in minikube, right? It's got 2 or 3 services, put it in minikube, put it in Docker Desktop, for example, and you're good to go. But there comes a point where the services get too numerous. Then folks often try and run a few things, just a few things in containers, right? There's many solutions out there. I love Docker. I'll do a Docker demo later on. DockerCon was yesterday, and there's some exciting new announcements that I can share today as well. But there's many solutions out there. I love minikube, particularly playing around with more ops-focused stuff. MicroK8s, K3s. There's lots of options for playing around locally, and these are definitely good options in your toolbox. But things like Telepresence give you more tools in your toolbox, right? The challenge often, right, is when you've got a laptop. I think this one's got like 64 gigs now, but if you've got like that company issued laptop, right, and they say, right, you're running a couple of JVMs, you're running a Kafka cluster, got a database in the mix, right? Poor laptop. Like, this is an Intel chip and it's smoking with Zoom and Slack sometimes, right? Let alone put a couple of JVMs on it. I'm hoping to get an M1 soon. Help that out. The second thing is the production versus local dev debacle, right? You're trying to run a few of your services locally. Is it really production-like? Probably not, right? This is a bit of a challenge. I've definitely seen quite a few times. You can definitely mock and stub and do a bunch of other things. I'm definitely not against things like Mockito. Love Mockito. Love WireMock. Love test containers. There's many solutions out there, but sometimes you want the actual thing. You want to be connected to a production-like cluster for testing. And this is where Telepresence comes in. Telepresence called a bunch of different things. As I bumped into it, I think 5 years ago when I was doing a lot of Java dev. I actually joined the company because I liked the tool so much afterwards. But it's called, Fancy Kubernetes VPN for development. Folks that use a VPN, you'll definitely recognize the VPN-like characteristics of Telepresence. It's kubectl port forward on steroids, I've heard some folks say to it. Folks used to doing kubectl port forwards. You get to see that sort of in the tool as well. Or it's kubectl proxy, all the things. This one's not quite so well known, but you can kubectl proxy into the Kubernetes API. Not super useful, but if you proxy all the things, that is super useful, right? Fundamentally, think of it as a network bridge between your laptop and a remote Kubernetes cluster. Make sense? So I can literally curl something, and I'll show you in a minute, from my local laptop as if I was in a remote cluster. And I can interact with anything that's network addressable in that cluster, which is super good, not only for curl, but when you're actually testing your software. I'm going to do 2 demos today. I just wanted to, they're a bit meta, so it skews the kind of basic architecture, but hopefully it's good enough to explain the concepts, right? I'm going to show you a very simple web app with a very large Java service, a data processing node service, actually Java service, and a sort of synthetic very large data store. Now these are actually just 3 Spring Boot apps, but I'm using it to simulate the kind of like the very large Java service would be the monolith, right? It calls out to the data processing service. The data processing service calls out to a very large data store. The chain completes, and then the very large Java service renders a web page, right? Pretty standard microservices style architecture. But what I want to do is I want to work on the data processing node service, but I want to call it via my normal ingress. I want to call it as a user would. Make sense? But the data processing service also talks to the very large data store. So if I'm trying to spin this up on my local laptop, back in the day when I was doing some of this stuff, we'd have to create these payloads to synthesize a real request coming into the data processing node service. And then we'd have to mock out the very large data store. Make sense? Now with those, the fake payload and the mock data store, I'm encoding assumptions into those mocks. And that can be good. Very fast feedback, great for speed, but sometimes you don't want assumptions. You want the actual real thing, right? I can't run, for example, say I can't run all these 3 services on my laptop because it's just going to smoke the CPU. What I want to do is take that data processing node service and move it to my local machine, but still be able to connect in to the cluster. And this is kind of how it's going to work, right? Telepresence, command line tool, download the binary, all operating systems supported. Once you do Telepresence connect, and you've got RBAC permissions, so just to be very clear on this, Telepresence is built with security in mind. You don't open up your cluster. Someone always asks me about that, and I can go into more details later on. But you do Telepresence connect, it installs a traffic manager service, and then it also installs a sidecar next to our target service we're going to be working with. And if anyone's familiar with the cloud native space, it's actually an Envoy proxy. Envoy is kind of everywhere at the moment. We're building on, standing on the shoulders of giants, an Envoy proxy. And what happens is because that proxy is routing or intercepting all requests to the data processing node service, we can make routing decisions and forward it onto my local laptop instead of routing the traffic through to the data processing node service. Telepresence also sets up a tunnel. This is actually slightly old tech now. We do some slightly different stuff, but a secure tunnel into the cluster. So not only can traffic come to my local machine, but I can access the services in the cluster. That's the idea. So traffic comes in via the ingress. I'm using Ambassador Edge Stack. Any ingress is fine, right? Nginx, Kong, pick your ingress. Hits the very large service, goes to the proxy that we've set up with Telepresence. That routes to my local machine over a secure tunnel. I can make requests back into the cluster via a secure tunnel and get super fast feedback hitting the ingress as I would as a normal user. But some traffic is coming to my local machine. Does that all make sense so far? Awesome. Demo time. I always love doing live demos with a network-dependent tool, right? Makes my day. You can guarantee something's going to go wrong. But there we go. Let's give it a try, right? So what I've got here is, it is a bit meta, but the web page of the 3 services I talked about renders the architecture on the web page. Notice we are in green, hopefully it shows up, this green font, and it also says on the second line or third line, the contents of this page were generated from the cloud environment, right? So I'm just hitting a standard ingress. We own the edgestack.me domain, so you'll see me use that, but it's like a standard ingress. You can hit it up if you want to as well on your browser. And then behind the scenes, excuse me, jumping around a little bit. If I just clear this screen and do K, hopefully everyone can see this. K get service. K is alias for kubectl in the Kubernetes world. I'm just saying get my services. You can see I've got my 3 services, right? I've also got a blog app in there, but I've got a very large Java service, that monolith, got my very large data store and a data processing service running in the cluster. And you can see the ports exposed there as well. Now, what I'd love to be able to do, I've got a cheat sheet here, just saves me typing super slow. What I love to be able to do, I know as I'm coding away in my inner dev loop, I know there is a color endpoint on the data processing service that I want to hit up and see what comes back. And I'd love to be able to do this kind of thing, right? It kind of makes sense. But clearly I can't because that's in a private network. within Kubernetes, right? Kubernetes spins up its own network. I can't curl into Kubernetes. I could port forward, I could do some other stuff, but I can't, by default, access the service.namespace. So sorry, folks not familiar with Kubernetes notation, I'm curling in the data processing service in the default namespace on port 3000. We can see it running on port 3000, bottom line of the command, and I know there's a /color endpoint. And it skews the American spelling and my American accent sometimes. I work with a lot of American folks, so I drop into American spellings and accents sometimes. But I know there's an endpoint, but I can't curl into it, right? What I can do now, if I do telepresence connect, I've already got telepresence installed. I won't bore you with installing that. It's super easy. We are good to go. I'm actually going to do telepresence logout because I want to keep it super simple demo at the moment. What I'll now do, I've logged in with telepresence. It's spun up that traffic agent in the cluster, installed my proxy next to well, actually, yeah, we haven't installed the proxy yet. I'll get to that in just a second. But if I now curl, I'm getting green back, right? So telepresence has put my laptop into that cluster. Does that make sense? All the services in that remote Kubernetes cluster are now available to me. And not only can I curl it, but I can, in my app, instead of actually doing crazy port forwards and renaming things, whatever the app's deployed with, data processing service .default port 3000, that'll run fine. Now that we've got this bridge from the local laptop into the remote cluster. Is that making sense so far? Awesome. What we'll see now, and excuse the slightly gnarly command, I'll walk through this. We're going to intercept, right? So I'm going to intercept the data processing service. I know it's on port 3000 from my Kubernetes command. Don't worry too much about this. This is just setting up the host details. This is my host name. We're hitting up the ingress right. I'm using port 443 because I'm running TLS as well. So I'm just shortcutting the command line options, just saying set up an intercept, route any traffic in the remote cluster for data processing service to my local machine. That's all I'm doing there. Hit return. Telepresence whirs away in the background. We are good to go. So now let me spin up a version, not that one. I've got IntelliJ here. This is a version of the data processing service in IntelliJ, right? So I'm just going to spin it up in debug mode. Hopefully it's clear. You'll also notice I've set the default color locally to blue. We saw green when I hit the first page, right? But I've set in this locally running version, and I'll try and leave the debug visible if I can, to perhaps to the side as we hit up the web page. So it's going to watch maybe the Spring Boot debug down here as well. But if I now hit refresh, right, I'm hitting the same ingress like my domain name. Hit refresh. Oh, Norton's just getting in the way. We see blue. Does that make sense? I've hit the ingress. It's now going through, and when the traffic is meant to go to data processing service, it's getting routed to my local machine. And I can access the stuff in the cluster. So for example, to extend this a little bit, if I now go into the data processing controller here, right, I'll set a breakpoint, because I ran it in debug mode in IntelliJ. I set a breakpoint. Now, providing I've set quite an aggressive or quite a loose ingress timeout, I can debug and return data to the user watching, right? So if I hit refresh, breakpoint gets triggered, right? You can actually see I've got my default color blue. If I try and edit, edit this, where is it? View edit text. If I then change blue to say orange, hit set, return that to the cluster, voila. Now, I'm only changing colors here, right? But imagine that fast feedback loop I can get because I'm literally testing it as a user would. So just a side note, anyone hitting this ingress URL is going to be hitting my machine. So don't do this in production, right? Because you're going to be serving traffic from your local machine, particularly with breakpoints. It causes a lot of problems. But you imagine that fast feedback loop, right? I can literally test something. I can be running a test suite, I've forgotten the names of them now, but like some kind of UI test, right? And seeing the results as I'm changing things live. I can be pairing someone with someone remote. And I'm like, hey, check out the URL. I've changed the API style. Does that work for you? Like, yeah, cool. They can literally see it live. No need to Docker build, Docker push. We can just super fast get that feedback going on. Does that make sense? Awesome, awesome. Let me just check my cheat sheet notes of where I think that's pretty much it for this bit of the demo. looking good. We're good for time. I'll press on for the Docker demo and then maybe pause for questions because I'm conscious some folks might want to sneak out for lunch. But let me just Telepresence quit. All done. So I don't know if folks saw the DockerCon ran yesterday. So DockerCon it's a virtual event, and I think it was based in the Pacific time zone, so hence I was up quite late last night. But one thing Docker announced was there's now an extensions part of their Docker desktop. So I don't know if folks have seen this yet. It's kind of hot off the press. So Ambassador Labs was one of the founding extension creators, like Sneak, who you'll see downstairs, Aqua, Octeto, a bunch of folks were one of the founding partners as well. But now, if you fire up the latest version of Docker Desktop, you can install it. It's like 4.8.1 is out there, I think. You will see an extensions marketplace. So you can actually go manage extensions, marketplace. And the idea that Docker have got is they're putting all the tools that you use day in, day out into the Docker UI. No need to drop into other tools or drop into web-based interfaces. You now can install standard kind of marketplace stuff, right? There's a whole bunch, I think it's 15 different extensions you can play around with there. And you'll notice Telepresence is one of them, right? So this gives you a different option because not everyone is super comfortable at the command line. Definitely I get it, right? As I love the command line, but typing those commands for some folks, it either becomes just magic, they'll copy paste, right? Or it's just it just puts people off, right? And I get it because, some folks are more comfortable in the UI, right? No problem. And this is what you get with the Docker desktop. So I've already installed the Telepresence UI. The big difference, for better and worse, is you have to be running the service in a container on the host network to be able to get the intercepts to work. Does that make sense? So whereas before, I was just spinning up IntelliJ and I was running it as a process on my local machine, straight up normal Mac process, right? Whereas now, if I want to, it's a simpler interface, you'll see this, but the caveat is I have to run my applications within a container. And if you're using build packs, which I'll run you through, got hot reload going on there, it's actually not a big deal. What I do, and I'll show you in IntelliJ, is you can mount a volume with your source code into a container with hot reload, be modifying code in IntelliJ, and seeing it rebuild automatically in the container. And if you really want to debug, you can do remote debugging into the container as well. That gets a bit more clumsy, but that's the idea. Right, let me bring up my cheat sheet to show where we're at. So I've got in my second window here, clear it up, do kubectl get service. You'll see, hopefully, 3 services. I've got an emoji Java Docker service, web Java Docker, and a user Java Docker. Let me just go into the web page and show you. So it's a real simple, I don't know if it's going to actually work. Oops. It's a real simple web app, right? Similar kind of deal, apologies, not great text there, but I'm making a request. I'm hitting the web service. The web service is calling out to a user service, getting a list of users, and then the web service gets those lists of users and calls out to the emoji service. And there's a favorite emoji listed with an emoji code in the user service. The emoji service just decodes that emoji. Right? So you make a request, you get a list of users, the web service then calls out to the emoji service and gets the proper code for the emoji. And what it actually looks like is super simple, right? Again, Spring Boot app, timely front end. I just did this for a DockerCon demo. And you can see a bunch of characters there, hopefully, right? My name, for the names there. And we've only got one whale being rendered. And for DockerCon, this was not allowed. DockerCon insisted on at least 5 whales. So I thought we can change this live, right? And just override that everyone now sees whales next to their name. We're going to hack, change, modify the user service running in a container. So we've got our URL there. That all looks good. Let me look at the cheat sheet. And I'll show you how I've actually built the container later on as well using using Pack, which is a CNCF build pack tool. So what I'll do now, that looks good. Let me set up Docker. So I'll go into the Telepresence extension, standard Docker, get started. You'll notice it's much easier like doing it through the UI, right? I just set my Kubernetes cluster. I've only got the one installed there. Telepresence doing its thing in the background. You get a nice UI representation of the services running in your cluster that are now interceptable. You can see them down here, right? I've got an additional quote service snuck in there as well, but apologies if it's a bit small, but you can see 3 main services we're interested in. running all via the UI. No need to type any commands at the CLI, right? So I want to intercept the user Java Docker service. Click on that. It pre-populates with, I'm running on port 8081, and then I've got some ingress options, again, just to route through to the ingress. And what we're now going to do is hit the ingress, but we'll when it goes down to the user service, it'll be routed to my local machine. I just had a brain pause there for a second, because one thing I haven't mentioned, and it is really important for this bit, is we do rely on propagating headers through the stack, right? Because what you saw earlier, anyone hitting the ingress came to my local machine. So the joke I made about production, like you don't want to do that in production, right? I'm going to show you now how you get around that problem by using headers to indicate that I want to route selectively to my local machine, but leave everyone else just going straight through to production. Does that make sense? And I'm using Spring Cloud Sleuth, if folks are interested. There's many other options out there. Spring Cloud Sleuth, super easy. You know, a few lines of, I'm a big Maven fan, but a few lines of Maven, even simpler in Gradle, right? To include it in, and then I'll actually show you some code in a minute, but you literally just specify, in addition to the standard OpenTelemetry distributed tracing headers that come with Spring Cloud Sleuth, you can just add your own headers in as well. And I've just said we're going to inject a Telepresence header in a minute, and I've just said to Sleuth, please propagate my header along with the OpenTelemetry headers, the B3 headers you're propagating down the stack. But we do need to, we didn't recognize that we need to modify our code to propagate those headers down. I've had a few folks chat to me recently saying, like, can't service mesh do this magically? Not really, because you need to propagate from ingress, the header comes in. Whenever you make any outbound calls, you also need to make sure that header is included in those. So you need a shim or a library or something in your code to actually do that. And I'm using Spring Cloud Sleuth here. Hopefully that makes sense. If it doesn't, come and chat to me afterwards. I believe Josh Long's at the conference as well. Just mention anything Spring Cloud to Josh and he'll give you a fantastic demo as well. Right, let's submit. Again, you see no need to type in lots of gnarly commands. The Telepresence Docker Desktop UI just default populates a bunch of stuff. We've got our intercept all spun up here. I can click and I've got this what's called a preview URL. So this is the URL. It automatically injects a header into the ingress, and now we can use this to make some changes. So I've got my intercept up and running. Let me pop into, there's the user. I'll bring up a terminal. So this is standard IntelliJ, right? This is, I've got my user service loaded in. Shall I do it on, I can do it on, is that quite small? I don't know. I'll try and do it here actually. Oops, wrong one. I'll just paste in the command. Well, I'll best walk through it here. So this is the Docker run command I talked about, right? So I'm running my user Java Docker service. I'm volume mounting my present working directory / source. So I'm in the user service, right? I'm mounting my present working directory / source into the workspace / source directory of the container. So I'm taking my host source and loading that into the file system of a container. I'm making sure I'm on network host. Like I mentioned, for Telepresence to work in this scenario, you've got to be on the network of the host machine. And I'm exposing some ports, and I've got the RM just removing the container after we're done. So Docker run, I'm just running this. It's a container I've built using build packs. You can actually see the command above. We can go into that. If folks aren't familiar with build packs, they're amazing. Another CNCF project. You don't need to worry about sort of having all your dependencies on your local machine or spread across your local machine. You can literally just do pack, build, and it will build everything in a container for you. And it automatically detects what version of Java you need, if it's a Spring Boot app, bunch of other stuff. And if you do the env Google dev mode equals true, it does hot reload in the container for you. So any source code that we're volume mounting in, when I trigger a change in the source code, it will reload the Spring Boot app or reload the Drop Wizard app, for example, whatever app you got in there. So I appreciate it's a fair bit of setup. So come and chat to me afterwards if you do want any sort of more info on this, and we can perhaps walk it through a bit slower. But hopefully the setup kind of makes sense. If I now, I'm just going to use like the terminal. Oh, I've still messed it up in IntelliJ. I didn't copy paste it. If I do Docker run, there we go. Looks good. So I've just got this Spring Boot app now, but this is running in a container on the host network, right? It's not running, like, I'm not doing the standard debug mode in IntelliJ. I'm just running in a container. So if I now hit, if I get my preview URL over here, bring this up, paste that in, that should come up. Ignore that one. And you can see the same results as what we've got over here, right? So this is my preview URL and the other was the main ingress. So what I'll do now, if I go into the user service, I've got some conveniently commented out code here, right? This is the standard cheat we use. I'll uncomment that, recomment that, and this is a total hack, right? What I'm literally saying is we're going to hard override any emoji to be a whale. That's all. Rather than returning the users back through, I'm just saying every user now has got a whale emoji, like really hard-coded basic stuff. If I click, I'm just going to save this file. Watch what happens. They've got the hot reload going on within the container, right? So the container has recognized, the script in there, that I've changed the source code that is mounted into that container, and then it's done a reload. So like if you use the Spring Boot DevTools, that kind of stuff, same deal, basically. But it's quite nice. I'm coding locally, but I'm actually running the thing in a container. So if I've got some like really old gnarly version of Java or that kind of something you don't want to install on your local machine, running something in a container in a build pack or using build packs is actually a really nice way to not pollute your local machine. I like doing this with like Ruby services a lot. I've got, rather than having like RBM for lots of different Ruby versions, I now put Ruby in a container. It's actually quite a nice way to limit the blast radius of your of changing your actual machine. Right, so we've made our change anyway, so I'm hard coding, right? And now if I hit refresh, fingers crossed on my preview URL, boom, we get all the whales, because this is hitting my ingress, my user service, hitting my ingress, my web service, routing to my local machine, the user service, we're overriding the whales, and then when the web service calls out to get the emojis, it's all just over in whales, right? Now, the interesting difference, because we're using these preview URLs in the Docker desktop extension, is now if I go back to the main ingress and hit refresh, fingers crossed, we do not see any change. Does that make sense? Because we're passing this header down through with our preview URL, so we just auto-inject a header into the preview URL, and now I can share this with you, and you can see my changes locally. You go, hey, Daniel, I don't want whales, I want, some other emoji, and I'm like, cool, change it, no worries. But everyone else in production is just getting passed through to the main production services. So a nice way to isolate your changes, right? I think I'll pause there on the demo. We've got 20 minutes left. Let me just, I think that all hopefully makes sense. I've got a few slides that just run through sort of like, actually let's bring this back up, that run through what we've seen today. So the personal intercepts, just to like explain it sort of in graphical terms, right? This is the original project I showed, but you can see like different routes things are taking based on using Spring Cloud Sleuth, but based on the headers we're propagating down through. Like if I think this is so we make a decision, we pass through onto the normal service, for example, and then if the header's set, we can pass through onto my local machine. I've kind of mixed my demos, apologies a little bit there, I need to update this slide, but hopefully that kind of makes sense on this side. The key takeaway here is Telepresence installs this Envoy proxy next to your service, and it can make smart decisions based on headers. So you can set different headers and only route selected traffic to your local machine to get that fast feedback loop. A cheat sheet, really, I'll whiz through this one because it's more for when you're downloading the slides afterwards. Same deal here, no worries there. I'll go through a few things and then leave time, I think, for folks at the end to ask questions or leave early. So let's press on with the good, the bad, and the don't try this at home. So the benefits is that any tool that runs on your laptop, you can now use with that service running locally, right? But still interact with the remote services running in the cluster. You can connect to cloud-based resources. I actually do this a lot. So when I'm, say, on Amazon, shout out Amazon, right? I use them the most. I'm using, say, RDS to run MySQL. If I've got an external name in Kubernetes parlance on that RDS instance, I can Telepresence connect and use my local MySQL tools to access my remote cloud service of databases, right? Same with Kafka, same with anything you're running. As long as it's network addressable, and typically you use an external name as the kind of entity it's called in Kubernetes, I can now Telepresence connect and get that really fast feedback by querying the data stores, right? It's kind of like when you do like standard proxying, but imagine once you've done Telepresence Connect, you can look at your services, look at the data stores, all this good stuff. So it's the same network namespace. We do constantly keep changing this with some of the tech actually, but things like NS network, NS lookup and dig should still work. So if you're an operator and start going in, and digging things, NS lookup, you should get the results back once you're connected, because it's like you are literally a VPN sharing the network, right? Sharing the remote cluster network. And hopefully you can kind of see that fast in a loop, right? You can get going. If I'm testing assumptions with my remote cluster, or I'm doing some changes and intercepting traffic, I can get that fast feedback loop. I can share it with you so you can also see. Sort of the requirements, maybe the drawbacks, right? You do need a network connection. So I live in Guildford, and there's a famous bit like on the rail line where you get zero signal, and I can't do any work. I'm coming up from like Guildford to London. Telepresence, we've changed it now, so it's quite resilient. It will reconnect automatically, but if you've got no network connection, you're kind of stumped, right? Whereas if I'm traveling around or whatever, I do still love my mocks. I love my service virtualization, but when I've not got a network connection, I use other tools, right? You do need kubectl access to the cluster. And this is how we do security as well, right? Particularly at ops focus conferences I deliver this talk to, you can see people looking nervous straight away when I mention Telepresence, right? And they always come up to me at the end like, how do I stop anyone installing this thing? I'm like, that's a very fair question, right? But if you give your developers kubectl access to production, Telepresence will work. But why would you give your developers kubectl access? That's kind of what I say, right? As in, even me, like when I'm playing the developer role, I'm like, I want to make it a special event when I kubectl into prod or SSH into prod, right? When I worked at Not on the High Street, awesome company based in Richmond, we used to put on a red lobster hat whenever we were on prod, right? And it was like a hat of shame in some ways, but also a hat of alerting folks, I am on prod, I am messing around, I might be doing something dangerous. I say to ops folks, please give developers access to, kubectl access to dev, but don't give them access to prod. If you haven't got kubectl access, and you control it via RBAC, typically, you can use webhooks, a bunch of other stuff as well. But if a developer, myself, if I've not got access to a cluster, Telepresence will not work. So that's nice, right? As an ops person, you're safe. Like if I can't kubectl in, Telepresence will not work. We do support all modern OSs now. Like the community's done an amazing job. Like Windows is a bit of a challenge, but Mac is very popular. A lot of folks on Linux, and I think like we're trying to make the Windows experience a bit better. But again, community effort there. So yeah, but all OSs should be supported with Telepresence. And if it's not, let us know and perhaps get involved. The most gnarly thing to us is VPNs. I'm sure many of you use corporate VPNs, right, for your day jobs. Yeah, because like we're using some VPN type tech under the hood, sometimes they collide. So people raise issues and we fix them, the community fixes them, other contributors fix them. We're gradually knocking down all the VPNs. So you should be good, but just a heads up, if you're using a VPN and like using Telepresence with it as well, you may bump into some weird things. Just let us know. Raise an issue on GitHub. My colleague, Jose, did a fantastic deep dive into how we implement the tech. So if you're interested in this, we use a ton device, we use Envoy proxy under the hood as well. If you want to deep dive on how the tech works, or your ops folks want to deep dive, this is the blog post for them. I get a few folks often say, classic hacker news comment, right? Why is that Telepresence so big? Why should I use it? I could build a proxy in a weekend, right? And yeah, you probably could, but it's a classic kind of hacker news thing. You've got to think outside the box here. Like, I would not recommend. I've seen, like, I don't do too much engineering on Telepresence, any at all, really. The team is amazing in Ambassador Labs. The community engineers are amazing. So many gnarly things. Capturing DNS, super tricky, particularly across all the different platforms. Maintaining proxy connections, like when it drops out on the train, that kind of thing, super hard, right? Kubernetes has so many different resource types, stateful, non-stateful, daemon sets, there's lots of different things. No two laptops are alike, trust me when I say that. Like you even saw Norton's helping me out, jumping up there. I hopefully disabled that. I obviously did not. So every laptop is different, right? There's Norton's installed, there's antivirus installed, there's firewalls installed. And of course, no two Kubernetes clusters are alike as well. So yeah, you can do your own proxy, but how maintainable will it be is my general advice there. It's a CNCF project, right? Get involved is the thing. It's open IP. You can see the GitHub issues. You can see the code. You can play around with it yourself. There's a whole bunch of folks that have contributed, have used it. So I'm a big fan of pooling our efforts, right? Rather than doing our own thing, the kind of classic Hacker News response, let's all contribute our efforts around this one tool. Or, yeah, there's many other tools too. You can see Telepresence hidden away down the bottom in the CNCF landscape there. So wrapping up, I talked about developer productivity at the beginning, right? This is all what these kind of tools are for, and think about the platform you're building to support your apps and so forth. And I wanted, there's a fantastic quote from Kelsey Hightower. Hopefully many folks know Kelsey. He's a luminary in the Kubernetes space. And he did an intro at DockerCon yesterday, last night. And he said, you don't want a 10x developer. What you want is someone that can come in and make 10 other developers more productive. And I really like that quote, right? And that's what I think a lot of us are doing. And shameless plug for my KubeCon talk, right? But I will bring this back to Telepresence. There's a lot of us now are really thinking about platform engineering, making sure, like with all these microservices, Kubernetes, containers, all great tech. But we as developers just want to code and ship stuff, right? And there's so many new things in the mix now. Like I worked with Heroku and Cloud Foundry for a while, and it was lovely. CF push. No worrying about all the deployment pipelines, no worrying about a bunch of other stuff. Granted, it's not quite as flexible as all these other tools, but there's definite focus at the moment on how to build a platform. We as developers should be leading that, right? Saying to our ops teams, hey, this is what I need from a platform. And I think tools like Telepresence are critical, yeah? Because a lot of ops folks, in my experience, and I've worn both hats over the years, but a lot of ops folks don't think about the fast feedback loops that we need as developers. So just one example, Telepresence can really help that fast feedback loop. There's other tools in the mix too. But do think about that developer experience. Think about when you bring a new tool from a conference, because you come to a conference, right, and it's tool city, right? Everyone's like, try my tool, check this out. And we go home a bit like sort of stunned. But do think about how all these tools you're playing around with fit into your platform. And all you're trying to do really is code, ship, and run your stuff, right? And if you are online next week, I'll talk more about this at KubeCon. Wrapping up, so you saw, and hopefully a few of you can recognize the pain, the inner dev loop when you've got many things and many infrastructure layers can be more tricky. Microservices, Kubernetes, love it, but it does make my life as a developer more tricky. Telepresence proxies your local machine into the cluster, get that fast feedback loop going on, enables the Remocally development, right? The remote to local development experience. You can route remote traffic to your local machine, route it back in the cluster, change stuff really fast. But it is all about being more productive. That's the key thing. That's why these tools were created many years ago. A bit of a CTA for you, a bit of a call to action as well. And please do get involved. Like even just helping with docs or raising issues, is really helpful for the community. So if you like what you've seen today, come and chat to me afterwards. I'm only here today, unfortunately, I can't be the next couple of days, but you can always find me on Twitter and other places and just reach out to me and I'm happy to get involved. A few examples, a bonus slide actually here. Let us know if you're a user. Docs and workflow, super important. And there is also a Slack channel. You can, A8R, ambassador, a8r.io/Slack. Yeah, if you want to jump on, ask some questions, a great community around there. Got 4,000 folks, I think, in that community now, where you can ask questions and get involved. And I think at that point, I've got a bunch of references here. I'll share the slides later on, so you can click all these links. But yeah, if you want to ask any questions offline afterwards, db@datawire.io, strange email address for various reasons. Probably best to find me on Twitter, LinkedIn, GitHub, all the places at Daniel Bryant UK. I'll say thank you very much. Happy to take questions, but if folks do want to leave, I appreciate that too. So thanks for your time. We've got, I think, about 10 minutes left if folks do want to, and there's a mic kindly floating around the room as well if anyone does want to ask any questions.
Hi, thank you. Great demo. I just had a question on one of your demos. You showed where you run a Docker container and used Telepresence.
Yes.
With Docker Desktop. Is it possible to do that without Docker Desktop, like another version of Docker, like with Colima, for example, which is an alternative to Docker Desktop?
Yeah, so you'd have to run Telepresence sort of outside, because the Docker Desktop extension obviously is kind of very coupled into Docker, but not coupled into the runtime of the container, if that makes sense. So yes, totally. And in terms of like the build pack tools, that's totally been done in mind. So you could spin up, use something else like Podman. A bunch of folks are bumping into lots of these kind of tools, right? It's not connected, like Telepresence is not tightly coupled with Docker as a runtime. We like the Docker folks a lot. We like their tech a lot, but we appreciate everyone wants options, and Telepresence is not tightly bound.
Thank you.
We've got a question. Oh, with. We have lots of questions now. Sorry, the mic coming around. I'll have to go for that one. Hello.
We have a particularly weird setup in our internal environment where we have to have our own root certificates that are issued by the company, which effectively means the company man in the middles all of our VPN traffic, and it breaks a lot of CLI tools such as the Azure ones and the AWS ones, so they just don't work out of the box.
Wow.
I know you said it generally does support some of the more quirky VPN features, but does it care if the SSL signature is wrong at your end? Because it will always be invalid in our network.
Oh, that's a great question. So I think it will, but best thing to do is maybe kind of chat to me afterwards and I can set you up with some folks, or try it is the best thing. Because a few times I'm like, that'll never work, and it does. And other times I'm like, it's so simple, why does that not work? And it doesn't. So yeah, great question. I'm not exactly sure on that one, but we can find out. I think it was 10 years old.
Thank you. Great demo, first of all.
Thank you.
In the first part, you showed where you use Telepresence to access your local running application to the database or the storage, whatever, in the cluster.
Yeah.
Is it possible to use Telepresence also to access Kubernetes resources like config maps and secrets using that, or is it just the SVCs to intercept the traffic?
Yeah, thank you. That's a great question. So yes, I should have mentioned that. That is a great question. So you can mount volumes, for example, remote volumes locally. We use SSHFS. So that's quite popular. Folks often loading config maps into volumes or that kind of things. You can totally mount them on your local machine, and it's a two-way interaction. So you can mount volumes locally. You can see environment variables as an example. So a lot of folks use environment variables as a way to extract all the environment variables in a pod, or be a pod with containers, and you can load that into IntelliJ as well. So hopefully that answers your question. Most of the things, like the combination of the volume mount and the environment variables, because it's like you're sort of execing onto the pod, you can usually find out most of the information you want.
Could you expand a little bit more about the preview feature that you showed? What exactly is happening there? I mean, we're not accessing our ingress directly. So how does that work?
Sorry, I did sort of skip over that. So it is in our community edition of so that's a product sort of connection there. Whereas the stuff I showed you in the first part of the demo, all 100% open source. The preview bit it's free, but it does require a connection to our cloud. So Ambassador Cloud. And what happens is we are hitting the ingress, but the preview URL routes first to our cloud product. It injects a header into a request it makes to the main ingress. If that makes sense. And the reason we use Ambassador Cloud as an example is we currently only allow folks from the same GitHub organization to view preview URLs. So it's not a case of that you create a preview URL and anyone can access what you're doing. You have to you sign in, you're from the same GitHub, or for security reasons, we insist you've got to. You can override this if you want to, but by default, we do a check to say, is this user accessing logged in, same GitHub creds, same GitHub org, sorry. If they are, then we'll inject the header. So that header then, so it's a normal ingress request with a header set, and it's x telepresence-id is the header. And then I've got, for example, it's a good question, because I've got my ingress set up to forward all headers. You probably don't want to do that in production, right? Because people do use it as a malicious attack vector. But I'm just saying forward all headers for convenience. And then Spring Cloud Sleuth, I'm again forwarding on all the headers down my call chain. But again, we've got this working with Nginx, other things. As long as you can route a header from the ingress all the way down through to the target service, you can then make that selective decision based on the header information that's propagated through. I'm hearing myself say that. There's a lot of words there, but does that make sense?
Yeah. So could I get sort of the same effect? Obviously, I'd have to make a change in my request, but hitting the original ingress and adding that header.
You certainly could. Great point. Yes. Yes. There'll be no security check there. So if you give the token away, anyone could use it. But yeah, 100%. And if we got Docker, I could even. No, I've only got 2 minutes left. I could even probably just show you that on Docker Desktop, but that's we're a bit tight on time. But great question, because there is a bit of sort of magic, so to speak, like there with the preview URL. So super convenient because you don't expose all your changes like to everyone, but there is a bit of like setup required in terms of propagating the headers and the way you introduce headers as well. So great question. One final question, then it's time for lunch after that, I think.
Is it possible to have multiple users connecting with Telepresence to the same cluster?
Oh, it's almost like I set you up in the audience. That's a great question. I should have mentioned that too. Yes. Yes, you can have multiple folks intercepting the same service even, right? So very common patterns. We actually use all our tools internally at Ambassador Labs. We can drink our own champagne or eat your own dog food, as some folks say, right? So we frequently do this where we're working on one service. A developer's a pairing. So they've got like this preview URL, they're pairing, then another pair of developers over here spin up another intercept with a preview URL, different header, but it's like one proxy. The proxy makes a routing decision. It either goes to this pair or that pair. So multiple developers can be sharing like the same cluster. Very common pattern, I should have mentioned this, it is a genuinely great question. A very common pattern here is have one shared staging environment or dev environment and have multiple developers doing intercepts on different services. The thing you've got to be aware of is any state mutation. So if you're mutating databases, you might trip over your colleagues, right? But other than that, it's a great way to get save some money, right? One dev environment rather than like 50 or something like that. So thank you for the question. It's good. Cool, I think we better wrap up. I see it's flashing at me. Thank you so much for your attention. I know it's lunchtime. I'm sure we're all super hungry, but I really appreciate it. Thank you.